we're going to go over this problem right here. Let's read it out loud. Carl's team has been keeping a record of how many free throws he has made this season. The table shows his made shots are proportional to the number of attempts he had per game. Use an equation to determine how many shots he will make if he attempts 45. So the table's kind of been pre-set up for you, um, and it kind of has what you're looking for. So let's very briefly cover. Actually, no, I don't want to erase. Um, so let's highlight that real quick. Use an equation, very important. Determine how many shots he will make if he attempts 45. Notice that attempts are here in the table, and there's 45 already preset for you. So we just have to find this one up there right above the 45. This is what we need to find. But in order to do that, is very specific in that it's telling us we need to use an equation. So we also know that the table is proportional because we're being told that. Um, so in light of that, what we need to do is then come up with an equation using the constant of proportionality. So as we look at this table, right, there is no way that I can make any free throws if I don't attempt any of them, right? So the attempted definitely is the independent variable versus the made shots, which are depending on whether or not you make any attempts. So in this case, it's the made free throws is y, and the attempted free throws is x. So as you know, a couple of things. Our constant of proportionality, represented by k, is written y over x, right? So when we write that, we're going to have y equals kx, right? So when we've determined what this is, we're going to put that in to where k is in our equation. So 3 over 5 is usually 0.6 if you do the division, but we're going to keep it as 3 over 5, okay? So that is our constant of proportionality, as you saw right there, right? So I don't need that right now. So just to point out, this is our constant of proportionality. Okay, like I said, you can use the decimal if you choose, right? And just to confirm, we're going to go ahead and write 12 over 20. And if you divide each one of those numbers by 4, you're going to get the same thing of 3/5. So yeah, we have a constant of proportionality because those two match. So what we need is to find the number that goes in this pink shaded box in the table. That's going to also represent 3/5. And to do that, we know that this is x because it's in the x row. So we're going to put that into our equation, and the equation is y equals 3/5 times 45 because x is 45. So as you know, whenever we're multiplying by a whole number, we're going to write that over 1, or you can just type that in right into your calculator, which will be fine. Now, what you can do is a little manipulation, right? And what you end up with is 3 over 1 times 45 over 5. So we know that 5 goes into 45 9 times, and 1 goes into 3 times. So this is really 3 times 9. Okay, so y is going to equal that, and y equals 27. Okay, so that means that this has to be 27. So you can double check very briefly to see if that's the correct amount of free throws that he makes, right? So you can write 27 over 45 as your ratio, just like the others, right? And it has to be equal to the same reduced ratio. So please understand that if I reduce both of these by 9, then what I'm going to get is 3/5, which does match what we had earlier of the same constant of proportionality. So yes, our answer is indeed 27. He makes 27 of the 45 free throws, given that the table remains proportional. So that is our answer right there.